Imagine standing beside a wall built from stones weighing dozens of tons each. No cement, no steel, no modern reinforcement. And then the ground starts moving. The earth shakes violently. Buildings crack. Walls begin to collapse. But this wall, it moves with the earthquake. And somehow, it stays standing. For centuries, the Andes have been home to some of the most remarkable stonework ever created. This is Inca masonry, built without computers, without modern machinery, without the construction materials we rely on today. So how did the Incas create walls capable of surviving powerful earthquakes? Did they somehow make these massive stones impossibly strong? Or was that never the point? Because the most fascinating possibility is this. What if the secret to surviving an earthquake wasn't resisting the movement, but moving with it?
High in the Andes, there are walls that seem almost impossible. Massive stones fit together so tightly that even the smallest gap is difficult to find. Some blocks weigh many tons, and some megalithic stones may have weighed close to 100 tons. And yet, there is something missing. Mortar. No cement binding these stones together. No steel bars. No modern reinforcement. Just enormous pieces of rock, carefully fitted together. At first glance, this looks like a weakness, but that assumption is exactly where the mystery begins. Because these walls were built in one of the most earthquake-prone regions on Earth, and the Incas may have discovered something surprisingly modern. A building does not always have to resist an earthquake by staying completely rigid. Sometimes it survives by moving.
The Andes sit along an extremely active tectonic boundary. The Nazca Plate is continuously moving beneath the South American Plate. That movement creates powerful earthquakes, capable of producing enormous horizontal and vertical ground motion. Now, imagine a conventional stone wall. The stones are locked together with mortar. When the ground suddenly moves, the entire wall tries to move as one rigid mass. The earthquake pushes one way, then the other, again and again. Those rapid changes create enormous stresses inside the joints. Eventually, the mortar cracks. The wall begins to lose its connection, and once that rigid system starts to fail, collapse can follow. So the Incas faced a terrifying engineering problem. How do you build enormous stone structures when you already know the ground beneath is going to move? Their answer was almost the opposite of what we might expect. They removed the mortar, and instead of fighting movement, they designed the wall around it.
Think of an Inca wall differently, not as one giant object, but as thousands of individual stone blocks working together. During an earthquake, those blocks can make tiny movements. They can slide, they can rock, they can shift against one another. And when two enormous stone surfaces move against each other, friction appears. That friction consumes energy. Some of the earthquake's kinetic energy is dissipated through these tiny movements between the blocks. The wall doesn't simply absorb the earthquake like one solid object. Instead, it breaks the earthquake's movement into countless tiny interactions. Slide, impact, rock, settle, again and again. It is a remarkably simple principle. But then comes the next question. If the stones are allowed to move, what stops the entire wall from falling apart? The answer is hidden in the shape of the stones. During severe shaking, individual blocks can rock slightly on their bases. One edge lifts, the block tilts, its center of mass shifts, and then gravity begins pulling it back down. The stone settles again. Modern structural engineering has studied this behavior through the theory of rocking blocks, associated with George Hausner's work on the subject. In Inca masonry, rocking and friction can work together. The impact of a rocking block dissipates energy. Friction between the surfaces dissipates more, and gravity provides a natural restoring force. The result is almost hypnotic. The stones move, but they don't necessarily escape. They dance and return. But the Incas had another trick. They didn't simply make the stones heavy, they made them interlock. Look closely at Inca masonry. The stones aren't simple rectangular blocks. Their surfaces can have multiple angles and irregular shapes. At Cusco, the famous 12-angled stone is perhaps the best known example. But these complex surfaces aren't merely decorative. They create mechanical interlocking. If an earthquake tries to push one stone sideways, another surface can resist that movement. If it pushes in another direction, a different angle
becomes the obstacle. And at important wall intersections, some massive stones were carved to wrap around corners. This reduced the possibility of two perpendicular walls simply separating during violent movement. It's almost like a giant three-dimensional puzzle, but there is another detail that seems almost insignificant until you understand the physics. The walls weren't perfectly vertical. They leaned inward.
So, did the Incas build earthquake-proof walls? Not exactly. They did something more interesting. They understood that earthquakes cannot simply be stopped. So instead of creating a perfectly rigid structure, they created one that could move without losing its shape. Friction could dissipate energy. Rocking could absorb motion. Gravity could help restore the blocks. Interlocking geometry could prevent them from separating. Inward-leaning walls could resist overturning, and deep foundations could manage soil, water, and seismic movement. Building gradually, it wasn't one secret, it was a system. Stone, geometry, friction, gravity, soil, water, and an extraordinary amount of human skill. And perhaps that is the greatest lesson hidden inside these ancient walls. The Incas didn't defeat the earthquake by overpowering it. They designed their architecture to live with it, because sometimes the strongest structure isn't the one that refuses to move. It's the one that knows how to move and come back.